Hey everybody, this is Dave with D&E Performance, back with our second turbo timing tutorial. I'm sorry, turbo timing. Turbo tuning tutorial. And we are going to pick up where we left off at. But first, before we fire the map back up and we kind of you guys kind of start getting the basics of the KPA map. Let's go ahead and I will read a little bit more out of this tuning book. Kind of where we picked off before. And this is just more information regarding KPA, atmospheric pressure, and gauge pressure. Okay, so a pressure of 14.7 psi is considered to be 1 atmospheric pressure, or 100 kPa. 1 kPa represents 1,000 kilopascals. Also, a pressure of 14.5 psi is equal to 1 bar. So the two terms are very closely related in actual measurements and are often used in place of each other. 1 bar of boost, which indicates a manifold pressure of roughly 14.5 psi of gauge pressure, or 25.2 psi of absolute at sea level. These measurements are also the same as having 200 kPa of manifold pressure. When referring to automotive ECUs, we typically use measurements of kPa. Thus, an engine operating in vacuum would have a manifold absolute pressure of somewhere less than 100 kPa. And when the engine is in wide open throttle in a state where it has no vacuum, no boost, it would have a MAP value of about 100 kPa. When the engine sees positive pressure or boost, the MAP signal would be higher than 100 kPa. This means that a gauge pressure in the manifold of 14.5 psi of boost would be equal to 200 kPa, and a gauge pressure of 29 psi would net a MAP value of 300 kPa, and so on. All this may sound complicated, but it helps just to remember that less than 100 kPa is vacuum and more than 100 kPa is boost. And for every 100 kPa is equal to about 14.5 psi of positive gauge pressure. So that kind of just lays it out in simple terms. Just remember on your map that 100 kPa is you're in vacuum, and for every 100 kPa it's 14.5 psi. So we'll go ahead and we'll open this map back up. So we want to plot a dot. We've got 105 kPa at no, we're not pulling out any timing at all, either or way. We're not adding timing, we're not pulling timing out. So we'll go ahead and see if we can move this back. Move this back and put this right at about 100 kPa. So we're going to set this we're going to set our dot right here, so we know this dot right here lines up with the graph at the bottom 100 kPa. So well, this is just a kind of a simple layout for somebody who just wants to get things starting, you know, get things started. As far as the vacuum portion of it, this can actually be beneficial. Like I said, it can be beneficial to you if you're trying to dial in your idle circuits on your carburetor. But for right now, let's go ahead and understand. We'll go back to where we were. We're going to go ahead and set this dot right here, though. We're going to set that dot right there so we know that that's our threshold. This is when we're ready to go into boost and when we're also into vacuum. This is kind of our fine line right here where things actually start to happen. So we'll go back over here to the internet, and if we type in 250 kPa, we get 36.25. So if we subtract, so I pull up my calculator here. Come on, calculator. Move this over here. So if we take 36.25 minus 14.7 or 14.5, really not going to make a difference. We get 21.55. So roughly right around 21.5 PSI, give or take, call it 22 because that's what the box is set up for. So we know that on our map, let's pull our map back up, that this number over here in the corner, 250, represents 22 pounds of boost. We're going to see 22 pounds of boost here. If we have a turbo wastegated at 22 pounds of boost. So as we lift up on the graph, we are adding timing in. We are not taking timing out. As you can see up here where it says 247 kPa at 14, that means 247 kPa, and we're adding 14 degrees of timing. So if we went and did that to this engine, we would see at what was it, almost 22 pounds of boost, we would see probably catastrophic failure, because you're going to add 14 pounds of boost onto your already 31.8. I'm sorry. You're going to add 14 degrees of timing onto your already 31.8 degrees of timing. So that is not going to be good. You're going to see detonation. So don't go. So when you're in boost, you always want to take timing out. It's the same thing as nitrous. You're going to want to take timing out of the map. So at our 100 kPa, and we are rolling into boost, we had our boost mark. We'll highlight that. We had our boost rolling in at 3100 RPM at 30.9 degrees of timing. And let's just say we're going to do 22 pounds of boost. So what we would want to do, or what I would want to do, And again, every engine is going to be different. I'm not tuning your engine. It is I recommend that you seek a tuner out and have engine calibrations done on a dyno. It is always the best route to go. I know there's a lot of people out there that are, especially myself, that have budgets that we are all constrained to. But there's steps and things that we can do here to at least prolong the life of our investment. So let's start. We'll take this dot right here and we'll kind of move it, and as we're rolling into boost, so at 114 kPa, and you can go back over here to this right here and kind of see where boost is going to be rolling in at. You're only going to see about 1.5 pounds of boost at that point. Remember, when you're typing this in, so you got 114 kPa, you're going to minus 14.7 off of this 16.5, and then that's going to give you your boost pressure. So go back over here to the map. So we're only seeing about 1 pound or so of boost pressure, and as we're going down on the map, we're taking timing out of our engine speed map. So as that map graph goes down, you're taking timing off of this point right here. So you're rolling in, you're taking about 1 degree or so, 1.5 degrees or so of timing out on your engine speed custom 1 map. So if you keep going down with your map until you reach 250 kPa, you can kind of just take the arrow and follow it down, and then you can kind of see how much timing, total timing, you're taking out before you reach the 22 pounds of boost. So in this case, we're taking out at 22 pounds of boost or 250 kPa, we're taking out 29.5 degrees of timing. That's, you're going to kill the engine by the time it hits 22 pounds of boost. So what you can do is, whatever certain boost number you're going to set your turbo project at, in our case we're setting it at 22 pounds of boost, we only want to take out, say 10, let's just say 9, maybe, yeah, let's just say 9. We're just going to take 9 degrees of total timing out. So in this case, we would just want to come back up here and kind of plot, what did I say, 9 degrees? Yeah, I said 9 degrees, didn't I? Yeah, 9 degrees. Okay, so we'll take this dot out so we're not messing around with too many dots here and confuse ourselves. Oh, I can't get rid of that one. I guess that one has to be there. Okay. So at 149 kPa, we're taking 7 degrees of total timing off of our custom 1 map. And by the time we hit, let's see, where is this at? Kind of move this one up a little bit. That's fine right there. So as we're coming in to boost right here on our engine speed map at 3100 degrees, timing is starting to be taken out as this starts rolling down, and then however much timing you want to take off of your map, all you're going to do is just plot it either up or down, depending on how much timing you want to take out and where your motor is in general, as far as you know, where your AFRs are and all those other type of readings. So that is pretty much the basics that I can lay out here of the turbo timing and the KPA map. It's pretty straightforward. Like I said, anything under 100 KPA, you're just gonna want to go ahead and, you know, you could probably mess with this if you wanted to mess around with your timing, or I'm sorry, your idle circuits under vacuum, because you might as well try and tune this part, the vacuum portion of it. You can take timing out, you can add timing. So if you have, let's say right here, 30 KPA, and which I said it's going to be more like 60 KPA. You're going to see 66.7 KPA. See if we can find that. 66. Okay, 66. 66 KPA is, I don't know if we can get rid of this one. No, we can't get rid of that one. 66 KPA is going to be roughly right around 19.7 inches of mercury. If we go back over here to our, oops, not this. Come on. If we go back over here to our vacuum unit chart. So if we go over here, back over here to our unit chart, we can see that 66.7 KPA represents 19.7 inches of mercury absolute. That's, like I said, every engine's different. Some might be have a vacuum of 15 inches of mercury. Some might have 19. Some might have 10. It's all going to be determined on, you know, your cam profile and a bunch of other variables that go into that. But for the most part, this is where you can set up your graph on these baselines, and then you can just tune from here. So if this is what your engine is seeing, let's just say that our engine is seeing that, we can you know, add 2.9 degrees of timing, or we can add more, or we can even take timing out if we want. But usually under vacuum, you're not going to want to take timing. You want to add a little bit of timing. So if I was seeing this, I would probably just add, you know, maybe about 2.5, maybe even 2 degrees of timing. I would just start there and then see, you know, how the engine. This is not. You're not really going to see. It's not. The engine's really not going to see this much vacuum. So, so I would just see if the engine liked this, and then make further adjustments from there. But anyway, this is Dave with Dini Performance. I appreciate everybody watching my videos. Thank you for hanging in here. I know both of these tutorials are going to probably be super long. I know this one is, and the last one too. That's why I cut it. But if you have any questions, concerns, if you want to leave comments, go ahead. Please subscribe, like, share my videos. Again, visit my website. I'll leave all the links as far as all the stuff that I discussed in both of these tutorials in the descriptions. My website is an affiliate website, so anything that's purchased off of the website helps me fund these videos. It also helps me do product reviews, and it just helps me in general keep my website and all the information that I put out going. I appreciate it. Again, this is Dave with D&E.